Hello, my name is Chan, and I'm here to present you how the NodeMCU can use to detect the result of movements by RSSI, which is Received Signal Strength Indicator. First and foremost, what is data acquisitions? Actually, it is a process of automatically sending data from one or more sensors to an application or computer system is known as data acquisitions. And it also can perform the tasks such as changing the data solutions or delivering the data for processing fall under these classifications. And the DAQ system divided into two groups, which is analog and digital. Analog DAQ is the direct measurements of electrical quantities such as voltage, current, and resistance output for an analog DAQ. And for the transducers like LVDT and the thermocouple can also be used to generate analog DAQ. For the digital DAQ are typically employed for storing or presenting data, and namely, the capture of analog signals can also be conversions of analog signals to digital data. And the processing digital signals or actions on digital data are involved in digital data acquisitions. The NodeMCU RSSI is a DAQ hardware platform that can connect the items and transfer data wirelessly using the ESP3266. And it can program by using the Arduino like IDE language. It's one of the board's main characteristics. With a built-in antenna, these access points or stations can be used with event-driven API applications. The UBDOTS platform is a data analytics solution for the Internet of Things, which is IoT, and it converts data into information. And UBDOTS is a simple and cost-effective approach to incorporate the IoT power into this project. The UBDOTS platform will communicate all data relevant to RSSI readings to this IoT platform by using the ESP8266 Wi-Fi protocol. And now, I will show you the demonstration of this assignment, which starts with entering the program that is given in a Google Classroom, and what I do is that I add on the IoT platform library inside of it, and by changing the SSID and password to connect to my mobile hotspot. The NodeMCU is seen and connected to the laptop by using a USB. As a result, I can see the experience output in the Arduino serial monitor, and everything appears to be working. And I can observe the RSSI reading changing as I get the NodeMCU closer to the smartphone. Also, in order to make my assignment easier to iterate, I designed the notions of interpretations through distance of measurements using meters as the unit of measurements. In other words, I take 1 meter and 3 meter distance measurements between my smartphone and the NodeMCU. With these two distance between the smartphone and the NodeMCU, I can obtain this to stay in the middle for 10 seconds. And the purpose to standing is to see the RSSI increase. The reading drops as soon as I move away. Here is the video I made to show you how I operate this task. You can see how the result increases when I just place the NodeMCU between the smartphone and the NodeMCU for a period of 1 meter. For 1 meter, I can achieve a maximum reading for 60, and for 3 meters, I can achieve a maximum reading of 79. Thus, you can see that when I move away, the RSSI reading will decrease. As soon as I get the RSSI values, I can analyze by just capturing the reading every second within the time scale period. Therefore, I plot the graph to see the data I already have taken from the UBDOTS. Based on my readings, I have to calculate a few terms such as standard duration, mid, mode, medium, and variance. From the data, it seems that all is negative, so I change the positive number to make my calculations easier. For the first scenario, we have a distance of 1 meter, and we know that when we calculate the standard deviation, we must first discover the mean. Then we get 54.1 dBm from the data. The mode is when you see all a lot of value is the reading. So I'm receiving 51, 52, 53 and 60. So the median is the middle of the reading. So I'm getting 53 dBm. After that, I calculate a standard deviation of 3.348299 dBm and a range of 11.2111 dBm. For the second scenario, a distance of 3 meters, the mean is 62 dBm and the median is 59 dBm. And same for the mode is 59 dBm. For my standard deviations, I got 7.5427 dBm, and for my variance, I got 56.888 dBm. So based on the output, I have concluded that the NodeMCU can detect the coincidence of human from the distance I have measured, as the RSSI reading between the NodeMCU and the smartphone hotspot will also increase if the NodeMCU detects no human user. However, if you move near the NodeMCU, is to allow the NodeMCU to identify human user between the NodeMCU and the smartphone, and the RSSI reading for sure will be increases, since the RSSI can easily detect the human user even if there are no people there. Generally, this assignment is for the goal of detecting human user for safety reasons. Examples: this system can be used as a home security system to detect visits both inside and outside the house. As a result, I've learned a lot about using the NodeMCU, such as RFI to detect human user and the programming by using the Arduino. I also discovered how to upload all the data to the tb.lt platform by using the NodeMCU. As a result, I was able to finish this project effectively. And that's all from me. Thank you and goodbye.